Hello, we should be live. Just getting things set up. We should be good to go. Sorry, I'm just, I don't know why all of these... Sorry. Something weird happened. One sec. Howdy, howdy. Okay. Let me just double check that we are live on YouTube, and we should be good to go. Just open it up YouTube. Sorry, there we go. Audio should be a little bit better. How do you know if physics is the right path for you? It's a good question. Is it something that you find interesting and that you could see yourself spending, you could see yourself, you know, doing for the next 10 years or something like this? Because if not, then it might not be for you. Do you tend to get more YouTube viewers or TikTok viewers? TikTok viewers. That's where I started building my platform. Oh, my audio is kind of quiet. That's where I started with my platform, so it's definitely going to be where I get the most views. Hello to YouTube. Christopher Siebert with the $2. Does length contraction affect a wave function? Yeah, so yeah, it does, actually. Is the oscillating wall with Casimir effect to produce photons practical? I don't know what you're referring to when you say the oscillating wall. Could our universe be the result of what's coming out the other side of a black hole? Probably not. Can you explain gauge theory in simple terms? No, because it requires knowing what a gauge group is. But the simplest way that I can explain it is that, I mean, it's a mathematical thing. So by requiring that the way that we describe certain matter has certain symmetries, like, you know, if you rotate the matter, it stays the same or whatever. By requiring that it has those symmetries, that forces the additional behavior of the thing that describes the symmetries. These are called gauge fields, are the things that tell you how the symmetry property at one location changes between... Sorry, let me rephrase. Yeah, so if you allow yourself to like rotate your matter system in like an internal space at each point in space-time differently, then, and you allow that to be an equal description, so however you rotate this internal space, you always get the same answer for like the actual physics. The fact that the internal spaces can be rotated in different ways means that there has to be a way to connect them in a continuous way, and that way that you connect them is basically the way that we talk about forces nowadays. These are the, well, they're called connection one forms, and these are what are called gauge potentials. But there's not really a simple description of this, unfortunately. What is spin? Spin, well, it's like they're a tiny ball that's spinning, except they're not a tiny ball and they're not spinning. No, but really it's just intrinsic angular momentum. Oh, thank you, Discord announcement, that's right. All right. Right. I'm an engineer that had courses in differential equation, linear algebra, and vector calculus. I like to learn the basics of differential geometry, but the books I looked at jumped deep into manifolds straight away. Pick up Sean Carroll's Space, Time, and Geometry, because that book does it from a physics first perspective, which is quite nice. If you wiggle one of two panels when creating the Casimir effect, it is theorized to produce photons. Okay. What's faster, sound or light? Light. How does light bend around my fingertips? Diffraction. How can we observe electrons? If you smash an electron into something, it can cause the atom that it hits to give off light. That's one way. Could scientists create a black hole in some kind of lab environment? Not yet. We don't know how. What is the path of least action? Well, there's a quantity in physics called action. It's roughly, at least in classical systems, it's the difference between the potential and the kinetic energy. And the path of least action is the path through space that makes that number the smallest. With what you know now, what would you have done differently in college? Not much, to be honest. Actually, I think that Occam's razor proves that everything can be simplified to a common symbol. No, that's not true. Do you know about scalar waves? Yeah, the Higgs boson is a scalar field, but there are no electromagnetic scalar waves. Would doing a math undergrad to then do a physics grad if I'm planning on studying cosmology work fine? You'd have an easier time if you did a physics undergrad. Can lengths contract smaller than the Planck space is maybe what I meant, and is that a conflict between the two theories? So in principle they could. It's not a conflict, but it does suggest that the system is, that there should be some quantum gravitational effects, absolutely. Thoughts on the planet K218b? The scientific community isn't that excited about it, so you shouldn't be either. In what area of physics do you expect the next breakthrough comparable to relativity or quantum mechanics to be? These things are impossible to predict. Why can't I catch up with a photon? Because it's always moving at the speed of light, regardless of how fast you're going. How much do you know of thermodynamics? Enough to get a PhD in physics, I guess. Can you assuage my fears over the RFK autism registry? No. No, I can't. Tell us cool stuff about gravistars. Well, they're hypothetical. But they might be real. I made a video about them a while ago. Yeah, okay, yes, technically true. It is the total kinetic energy minus the total potential energy integrated over time. What's the craziest, that's what the action is. What's the craziest thing that can actually happen with science? Anything that happens in the universe can happen with science. Do things like flashlights store or create photons? Yeah, technically, yeah, that's the action. The Lagrangian is the difference between the kinetic and the potential energy. And then you integrate the Lagrangian over time, and that gives you the action. Do things like flashlights store or create photons? They create photons. Do you think Einstein had help from aliens? No. Faith in graviton discovery? Not in my lifetime. Yeah, Shiva, no, you got it right. Yo, Blitz, you see that guy call you out? What guy? Do things like, okay, do scientists speculate seriously on creating a black hole? Not really. I mean, I'm sure it happens, but it's not like something that anybody thinks that we're going to make soon. Why is there a theory that says that going inside a black hole could bring you into another universe if there's just a lot of mass that is compressed? Because we don't really know what's going on inside a black hole. Is that, like, at the end of the day, like, it's genuinely a mystery. Like, we have some guesses, but we really don't know. How much do you know about bending gravity? Well, you can't. Like, gravity is the way that we describe gravity is by the warping of space-time. LHC did not create any black holes yet. No, it didn't. Thoughts on StatMech? I don't like it. I don't like it at all. What does it mean for a photon to be its own antiparticle? Well, what it means is that all of the charges that it would... So the antiparticle of a particle is just what happens when you take that particle and then you swap all of the charges and you swap its parity. And, well, you don't have to swap its parity, but you swap all of its charges. So if it has positive electric charge, then the antiparticle has negative electric charge. If it has green color charge, then the antiparticle has anti-green color charge, and so on. But a photon doesn't have any charge of any kind, actually. So if you swap them, all of them go from 0 to 0. Can the mind connect to the quantum fields? No. How did you choose your field in physics? Because I thought black holes were neat, and I wanted to do that for the rest of my life. So how do you measure electrostatic per meter? Where's the perimeter measurements of gravity? I don't even know what that question means. Do you think simplifying physics to get the message across actually hurts the science? I think it can. What do you think of the holographic universe theory? I don't buy it. As far as we can tell, our universe is not ADS. It's not anti-de Sitter or not even asymptotically anti-de Sitter, which is, as far as we know, really like the only kind of sensible holographic description that we have of the universe. Furthermore, our universe isn't 5-dimensional either. At least that was the original holographic proposal. But, you know, I think it's a useful mathematical duality that can help us learn about how physics works in our universe. Have you done anything related to metrology? I haven't. Is the Big Bang still a leading theory on everything started in the universe? No, this is not the consensus that like that there was nothing before the Big Bang and that the Big Bang was the beginning of the universe. Is energy conserved? In most macroscopic systems that are smaller than, say, the size of a galaxy, yes. Once you get to the cosmological scale, all bets are off, though. Is Planck like the smallest possible time measurement, or could we have like half Planck? So Planck, the Planck scale, all the Planck scale indicates is where we expect quantum gravity effects to start to become important. It doesn't say anything about it being the actual minimum size, though. Wouldn't a gravitar just flatten out into an accretion disk? Not necessarily. So in a gravitar, if I remember correctly, there's some sort of internal pressure that keeps it out, that pushes it out. So, do you think we'll ever be able to travel light years? Maybe. Are you a materialist? Sort of. Do you believe in the Stephen Wolfram model? No. Can you explain what happens to space-time and black hole merger events? Well, there used to be space-time between them. There used to be normal, what am I trying to say? There used to be non-black hole space-time between them, and then they merged. Now there is no non-black hole space-time between them. Can space-time exist without energies? Energy is not necessarily a well-defined notion in space-time, actually. Could we even be living in a computer simulation? No, not really. What's the cutest elementary particle? The bottom quark. Space is huge and still expanding, but there is an end to it. What is behind that? No, there isn't an end. There's like the current scientific models do not have an end to space. I'm way behind. I have to jump down to the bottom. Could you push questions that are unanswered to ChatGPT? No, I'm not going to do that. 73 theories of gravity. Pick one already. 73 theories. Where'd you get that from? Do you support the idea that we live in a simulation based on a double slit experiment? No, that has nothing to do with simulation, and there's not really any good evidence of the simulation theory. In fact, there's actually good evidence against it. Could the neutrino be the graviton? No, a neutrino is charged under the weak nuclear force, whereas the graviton would not be. Okay, but what is the Lagrangian of the Standard Model? The Lagrangian of the Standard Model is the field strength tensor squared, plus the kinetic term for the fermions, plus the Higgs potential. That's it. Why do electromagnetic waves not require a medium to travel? Well, they do. They travel in the electromagnetic field. That's the medium. The medium is the electromagnetic field. It's just not like a physical medium made of stuff. Can we experimentally observe Hawking radiation, or is it purely theoretical? At the moment, it's purely theoretical, but we have good reason to believe that it's like true, that it's correct. Do we live in a black hole? I suspect not. Yeah. Gravistars, they have an internal kind of cosmological constant, if I recall correctly, that keeps them open for gravistars. How many bananas would it take to overpower the sun? A lot. Relating to energy is conserved or not is because Noether's theorem links energy conservation to time symmetry, which only holds in a static universe. Yes, it's exactly it. There needs to be a time there needs to be a time-like killing vector in order for energy to be globally well-defined. Can you explain evidence against simulation? So go watch my paper review stream from last week. We review a paper that shows that a simulation hypothesis is very implausible. How is it possible for it to be infinite? It would mean that Big Bang has an infinite amount of energy, right? Yes, it would mean that. Or is it because space has no air, so no energy? Yeah. Do you think Stephen Wolfram model is correct? No. Who's the best physicist of all time? It's either Einstein or Albert Einstein, or it's either Einstein or Newton. It's debated over who's better, in my opinion. Is it possible that materials with negative indices of refraction are possible in nature? I don't think so. Do you think the Animalia kingdom is just more mutated microbes inflated to look like... No. What is physics' best understanding of the concept of nothing? There isn't one. Can you explain what a manifold is? I'm not getting the corners part. Don't cubes have corners? Yeah, so a cube wouldn't... The surface of a cube is not well described by a manifold. By a smooth manifold, anyway. Manifolds, at least, like, smooth manifolds are smooth, right? How does light not escape a black hole when there is technically an infinite amount of energy to slow light down? I don't understand your question. So inside a black hole, there is no direction that points outwards. Like there just isn't one, right? So, rather, there are only inward directions. This is the only way that you can travel forward in time is by traveling inward. To what extent is the EM tensor F alpha beta analogous to the Ricci tensor? It's not. It's analogous to the Riemann tensor. But other than that, it is basically the same. It's just it acts on a different space. Is cosmic age measurement not affected by relativity? It's not really affected by relativity. We have a cosmic stopwatch that we use. It's the what is it called? It's the co-moving frame, which is the frame in which the cosmological constant. Sorry, not the co-moving frame. It is. No, I think it is called the co-moving frame. It's the frame where the cosmological constant is isotropic. Do you ever wonder about problems in fundamental mathematics like incompleteness affecting physics? No, it can't really. Because the point is if we ever run into a problem in mathematics, then we just do an experiment and we figure out what the math needs to do. Can you explain how gyroscopes work and what they aim to show? So all a gyroscope is it's just a thing that's spinning really, really fast and it has a lot of angular momentum. So because angular momentum is a conserved quantity, meaning that like you have to apply some external force in order to make it change, or in this case an external torque, if you spin up a gyroscope, it will just continue to point its angular momentum, which has a direction. Roughly, it's the if you curl your right hand in the direction that it's spinning in, your thumb points in the direction of the angular momentum. Regardless of what you do, it will stay pointing in that direction wherever you go. It will not deviate. So a gyroscope is a good way to fix an orientation in space. So if you have a gyroscope kind of suspended and then you turn, the gyroscope will turn, which will tell you in turn that you've turned because now it's not pointing in the same direction it used to be. How likely is it that the DESI results indicate that the cosmological constant is not constant? I think it's fairly likely, actually. Can viral curvature be used to classify or distinguish black hole spacetimes? Yes, it can. In fact, this is something that I'm working on right now with a colleague of mine, colleague and friend. But yeah, generally, I mean, it's not the only thing that can distinguish black hole spacetimes because there are black hole spacetimes that are conformally equivalent, but they're different spacetimes, and the viral curvature would say nothing about that. But it does give you a lot of information. Do you believe it's more likely the universe did or didn't have a beginning? I kind of lean towards not having a beginning, but I'm open to the possibility that it did. What does higher dimensions actually mean in physics? So we have 3 spatial dimensions: left, right, up, down, forward, back. But in principle, there's nothing stopping you from having more than 3, especially if those extra dimensions are curled up into tiny, tiny, tiny little volumes. Meaning that imagine like you could have a dimension that's kind of goes in a loop. Like imagine walking around on the surface of a tube. Well, that surface of the tube is a second dimension. There's along the length of the tube and then along the surface of the tube, but that second dimension is curled up. How do you feel about AI development in math? I don't have strong feelings about it. What does the acronym DESI mean? It stands for Dark Energy Spectroscopy Instrument. Maybe a better question would be, why is nothing able to get out of the gravitational pull of a black hole? Because the definition of the event horizon, well, one of the definitions of the event horizon is that it's the place where space-time is so warped that the only way forward in time is into the black hole. What would that mean, the universe not having a beginning? It means that it's always existed. Do you support the idea of quantum immortality? No, it's not like a real thing that people really take seriously. Well, philosophers might take it seriously, but physicists don't really. What prevents the universe from ripping since it's expanding non-uniformly? What would it mean for a universe to rip? It's just space. It's not like a material. Why can't we take detailed photos of exoplanets? Is it simply they're too far away? Yeah. Why do we magnetically repel things we want, need, but get it when we give up and I don't know what that means. Is it within the realm of possibility that in the big bounce model of the universe, the singularity at the beginning and the singularity at the end of time are entangled singularities? I wouldn't even know what that would mean, so I can't answer that question really. Like you can't. If it's a big bounce scenario, almost certainly they're not actually singularities. It's some finite size. Did you see the laser-cooled strontium atom gravity wave detector? I reposted that video, yeah. Universe expanding into what? It's not expanding into something, it's expanding within itself. Is it possible to create a career in physics? Yeah, go become a physicist. But why don't black holes begin the decay of spacetime similar to vacuum decay? Why would warping spacetime cause vacuum decay? What's the most fringe idea you hold in quantum physics or science in general your peers would probably disagree with? I don't really hold any fringe ideas. Why are your professor reviews so bad? They're not. They're actually quite good, although they don't exist anymore. When they did exist, they were quite good. Sorry, I got tagged in something. How significant do the DESI results alter our theories about the ultimate fate of the universe? Well, they have to be confirmed, of course. That we still need more data, but it would be a pretty sizable change, pretty big change. Sorry. Is water flat? No. Come on now, give it up, host. You know nothing. You're reading the script, and he brought something that. What? Oh, I have the hiccups. Oh no. Is it still within the realm of scientific possibility the universe is pre-eternal in some form, or is this now unreasonable? No, it's... If by pre-eternal you mean if it always existed, then yeah, that's possible. Blitz, drop science, and let's put a barbacoa food truck on Mexican. Trust me, I love barbacoa. I literally had a barbacoa burrito today, actually. All right, I'm going to bring up a guest to ask some questions. Open up. Friends get first dibs, then subscribers get second dibs.
How's it going?
Hey, bud. How's it going?
Good, thanks for having me up. So the other week you mentioned you had some growing issues with how Many Worlds plays out. I'm wondering what those issues might be, and if it happens to do with how probability arises.
Yep, it's just the Born rule. That's it.
Oh,
I mean,
okay.
you could just say, yeah, the Born rule is just an axiom, but you know, you'd like to be able to derive that.
Yeah, so I was watching. It wasn't like a formal debate between the two, but it was two separate interviews, one for, one against Sean Carroll and Jacob Barandez. And Sean Carroll was arguing two forms. One was that that is just how a rational agent would work in a world. They would assign those weights, and the counter to that was, well, if there's a chain of events where that agent might see, spin up no matter how many times they do their experiment, can they really be considered rational? And I was wondering what
Right.
you think
Yeah.
about that.
So there was a good analogy, and I don't remember exactly what it was, but it was fairly convincing. I'm not fully convinced on the rational agent business. Like, Sean Carroll gives some good arguments, but I've also heard some good counter arguments, and I don't remember them well enough to repeat them, because I heard them from a colleague, when there was some drinking that night. So, so I don't remember them fully, but I remember them being convinced. So I'm just less certain now.
Okay. That makes sense. I know there's supposed to be like a more updated version called the probability postulate. I just haven't had any chance to like look at it, but it seems like it might fall into the same issues. Other than that, the other question I had also from the same interview was Barandas was saying that Bell's inequality holds if you have a rigorous definition of what causality is. And he argues that because we don't, then that allows for some different interpretations of how that might apply to quantum mechanics. He's a advocate for like a fully stochastic process. And I'm wondering, what's your opinion on that? How does a rigorous definition of causality affect Bell's inequalities?
Well, yeah, I mean there are some like the Bell inequality basically demands that well, okay, what's the claim? The claim of the Bell inequality is that assuming there's no collaboration, assuming there's no non-local behavior, assuming that the variables are real, then such and such a thing should be true. Now, if you assume if you assume locality, then that gives you something about, that tells you something about causality, but maybe that's not the full story about causality. Maybe causality and locality aren't the same thing. Maybe things can have causal relations in ways that we don't really understand. So yeah, I mean, the Bell inequality is very, very robust for like kind of standard understanding of the world, but like many worlds gets out of it because there's more than one outcome from a given experiment. So like you can violate the Bell inequality without giving up one of those three things just by having some other thing that violates our understanding of how the Bell inequality works. And I suppose I'd have to listen to the interview, but I suppose that's probably what he's referring to.
Okay, yeah, it's like a 15-30 second clip. I can send it over.
Yeah,
but
sure.
That sounds about right. Yeah, that's all I have for today. Thanks for getting me some answers on that.
Of course. Take care.
Yeah, see you around.
All right, I'm going to take questions for another 15 minutes or so in chat, and then I will bring up another guest. Remember, if you're watching on YouTube, super chats get answered first. Right. What are some brilliant things you hope to come from quantum computers? I don't know. I don't really care about quantum computers, to be honest. You can say measurement outcome is a stochastic function of the prepared quantum state, but fundamental stochasticity is sketchy. Yeah, that's kind of how I feel, but who knows? Maybe it's right. I'm getting ready to take a physics class for electromagnetism and optics, calc-based. How to prep? Make sure that your calculus is solid. Make sure that your trigonometry is solid, because that's all optics and optics is trigonometry and electromagnetism is integral calculus. So just make sure those are good and you'll be fine. Can you talk about the spirituality and quantum mechanics? If I did, that would be like my 9/11. How inertia works. It's actually a deeper question than you might think. It's hard to say what inertia really is if you have a single object in an empty universe. But as far as we can tell, inertia is the thing that resists motion. Or changes in motion, rather. Can you explain how the Higgs mechanism relates to particle mass? So there's kind of the pop science answer, which is like, oh, it's like molasses and the particles get dragged through the molasses so they slow down and that makes them behave like they have mass. But really all that's happening is that you have a field and a particle, one of the ways that the particle evolves is through interaction with that field. And the precise way that the effect of that interaction is that it gains is that the equation that describes the motion is exactly as if the particle had mass. Are you married? I am. Why do scientists think they are theologians? I don't think they do, unless they are. Is local realism false? Locality is false, or realism is false, or no conspiracy is false, or experiments have more than one outcome. Was Lenz's law always this hard to understand? Lenz's law is just a rule about the direction of an induced magnetic field. Lenz's law just says that the induced magnetic field will be in the opposite direction of the it says that the induced potential, the induced electromotive force, is created in a direction that opposes the change in the magnetic field. Is inertia related to the strong force? No, not really. At least not as far as we can tell. What is calculus used for? Anything past like basic Newtonian mechanics. Even that requires calculus. How was the universe created? Who knows if it even was? I've heard that if the dark energy results were confirmed, it'd either result in a constantly expanding universe or one that would collapse. Well, yeah, so those are the two outcomes, but that's kind of... So actually, you can actually rule out... kind of a stable state, something called a long freeze. This is actually something that I did last year. You can rule out this phenomenon called a long freeze, where it kind of just like asymptotically approaches some fixed size. So yeah, those are the only two other options: expanding or collapse. Should I study theoretical physics in a university? Everyone tells me not to because of low payment. Look, no, you don't do this for the money. That much is true. Can you please explain how imaginary numbers can be used to explain real-world electricity problems? So imaginary numbers aren't like some fake made-up thing. It's just a compact way of expressing an idea For example, like people talk about complex numbers, which imaginary numbers are a part of, as like rotational numbers. So you can have like lengths, which are like real numbers, but you can also have rotations. And so if you want to describe things that have lengths and rotations, then complex numbers are useful. Why do honeybees defy the laws of physics? They don't. Can you explain quantum eternity, and do you believe it? So the quantum eternity theorem is just something that Sean Carroll said once. It's buried deep in a paper, but it's really not that deep. The idea is that the way that we talk about quantum mechanics is it's described by a Schrodinger equation. And a Schrodinger equation is a type of differential equation. And one of the features of that differential equation is under certain conditions, you can run the clock backwards forever and the solutions will still exist, and you can run the clock forwards forever and the solutions will still exist. So if our universe is described by the Schrodinger equation, quantum mechanically, then that means you should be able to run the clock backwards forever, and there'd still be a solution, i.e. there'd still be a universe. Why is relativity not proven? I mean, it is. It's as proven as anything can be. Thoughts on electron superposition? It's a real thing that happens. How do these fields exist? What is the infrastructure for them? Surely they can't just exist. They do. I don't know what you mean by infrastructure. They just exist. They are things in the universe. You want to talk about special relativity? Do you invite nerds on? I invite people on when they ask questions. Why can we prove ether but not gravity? You can't. Nobody has ever detected ether. What are your thoughts on consciousness? Could quantum physics explain some parts? I suspect not. Are we living inside a black hole? I suspect not. What are your thoughts on Laplace's demon? It's a neat thought experiment, but it's just that. What if light naturally causes the wave function to collapse? Maybe, but that could be experimentally tested, right? How if the universe is bigger than the speed of... How is it the universe is bigger than the speed of light? Well, I don't know how you compare the universe's size and the speed of light. Like, one's a speed and one's a size. That'd be like saying, how is 10 miles an hour bigger, or how is 3 feet bigger than 10 miles an hour? Like, it just doesn't make sense to compare them. Explain how cats defy physics. I have a video about that from 2 weeks ago. Last Tuesday, or from 2 Tuesdays ago. So this would be Tuesday, April 8th. Go watch that video. It was a live stream. Do you study thermodynamics? No, it's not my field to study. I know about it though, because I had to take the course. Divide by 0 gets cake. Thank you for the $1. $1. Does physics disprove libertarian free will in your opinion? Well, it certainly doesn't. Like, in physics, there is no room for it. Now, if you want to put something on top of physics, then you can, I guess. Have you ever thought of a collab with Professor Dave? Y'all are my favorite scientists. Well, I have. But I don't know if he's really doing that right now. I offered a collaborative debate with him on modern day debates, but he wasn't really interested. But otherwise, we don't really have much to collab on. Does the double slit experiment mean the existence is dependent on consciousness? No. What do you think about Microsoft's Majorana 1 chip? It was a lie, a fabrication, a hoax. What do you think about Veritasium's least action? I didn't see the video, but I didn't hear good things about it. Is asymptotic freedom aspect of strong force stronger or weaker compared to attractive nature of it? So asymptotic freedom is just saying that at arbitrarily high energies, the strong force goes away and basically goes to 0. How do you get good at differential equations? Practice. Have you ever seen the true night sky? Yeah, on top of Mauna Kea in Hawaii. What would happen if you traveled faster than the universe expansion rate? The universe's expansion rate is not a speed, so it doesn't make sense to say to travel faster than it. It's a doubling time. If you could ever have an objective answer to every physics question ever, would you? Yeah, that'd be cool. I do this because I want to know the answers. He's just regurgitating. He has not discovered crap. I mean, my publications say otherwise, but okay, you seem upset. That's a you thing. Can you explain how zero modes work? No. No. It's just motion. It's just literally translation with no oscillation. Have you had time to explore Dr. Yu Wang's gravity hypothesis? He hasn't put it anywhere, so I can't. So physics is just assumption that imaginary is real. What? What are your thoughts on the big crunch? It might be plausible. Can you further explain what you heard wasn't good about Veritasium's least action video? I just heard that it was like a poor explanation. But I didn't watch it, so I'm not going to comment much more than that. What do you think of social democracy? Seems okay. What have you published? Well, I'm not going to tell you the names of the publications because that would dox me, but I've had 11 publications in the last 4 years. Did you spend the night on the actual Mauna Kea summit? I was, I think like 1,000 feet below the summit, and we spent like an hour there and we took some photographs, and I was there for my honeymoon, so my wife and I took some like nice photographs there, and we got to see the like a dark night sky. It was really nice. Where do you have printed discoveries? In my publications. That's where you put scientific, you know, new things, discoveries, if you want to call them that. Does observing collapse the electron's wave function in the double slit? If by observing you mean interacting with, then yes. What's the most fascinating thing about the universe that's still unexplained? I think that black holes might be it, or maybe dark energy. What is CS gravity? Chern-Simons gravity? That's got to be a three-dimensional thing, right? I don't know. I haven't looked into it. I have a practical solution to the n-body problem. Well, I suspect not, because it's been proven that there is no such practical solution. What topics do you study? I do relativity and a little bit of cosmology and mathematics, in particular differential geometry. Where are my publications? In journals. Various journals. Some of them physics journals, some of them mathematics journals. Do you have any hobbies? Yeah, I play video games and hang out with my wife. Does that count as a hobby? How do they build the pyramids? With big blocks of stone. Can you explain the spin states? Yeah, they're either they're quantized amounts of angular momentum. Has the cosmological constant problem been solved? Honestly, I think so, but that's definitely not the consensus. Where are his questions coming from? From either back, like earlier in the TikTok chat because I was behind, or from YouTube. Which journal's example of one? Classical and Quantum Gravity. You seem very interested in trying to dox me, though, so I'm not going to give you any more information. Question for the physicist. Why are the laws of nature so merciless? Why is our existence just pain? It's not. It's only sometimes pain. What does differential geometry entail, and what practical applications have you used it for? I'm not an engineer. My job isn't practical applications. Differential geometry is it's the souped up calculus version of the geometry of curved things. You didn't prove that. The journal's name is Classical and Quantum Gravity Cable. That's the name of the journal. How can I get an A star in my A-level physics exam in 1 month? Study hard. Is there such a thing as space dilation like time dilation? No, there's not. There's length contraction. Can you explain like in 5 the Borg-Guth-Vilenkin theorem? Yeah, so the Borg-Guth-Vilenkin theorem is it's a theorem of classical general relativity, which is not quite right, but it's close. Essentially and it's a fairly easy statement to understand. Namely, it says that if the universe has on average been expanding for its entire lifetime, then it must have been smaller in the past, and it must have been even smaller further back, and it ends in a single, and eventually you end up at a singularity. But there are some issues with it. Can you explain a complex concept in simple terms? That's what I do in my videos. You should go watch them. Classical question mark? I don't know what that means. Is it worth getting a PhD in physics with its low salary? Does it come with a lot of freedom? Lots of freedom. If you don't do this for the money though. If the Desi is right and the universe recollapses, what happens to dark energy? Does it go to matter, dark or not? No, it's just gone. What do you mean by lefty? My politics are left wing. What do you think about the newly found chambers below the pyramids? I don't think that there's actually anything there. Is it true that we can only measure the two-way speed of light? Yes. This guy failed physics. I did? Oh. Okay. What are some good physics books to read? It depends on what you're interested in. Yeah, so it is true that Desi doesn't necessarily imply the universe collapses. That's just more on the table now. Nobody looks for answer with a physicist. People who, like, engineers do, right? Engineers absolutely do. All right, I'm going to bring on a guest. Let's bring on a guest from YouTube. Icon, can you hear me?
Hello?
Hey, how's it going?
Hey, great. Yeah, I just want to ask you like some questions I've been studying on right now.
Sure, go ahead.
Yeah, like in cosmology, I know this is like very heavily studied upon, but are you familiar? I mean, of course, I think you probably know like very deep questions about like nature of time.
Mm-hmm.
Like like there's a tension between like the A theory and B theory of time. Personally, I don't know like which view to hold. So like, can you like better help me explain like to understand each?
A theory of time essentially is that now is some real universal thing, and B theory is that all moments are equally real, and that there is no one preferred now.
See.
B theory of time is more consistent with relativity. So if you accept relativity, then you should accept B theory.
See, so like just to check my understanding, like is A theory kind of saying like there's like time is absolute and like the present is only like now or something like that?
It's more saying that there is a meaningful distinction between past, present, and future. That the past is actually different from the present, and the present is a well-defined now, and the future does not exist. Like that's A theory. That it's a tensed theory of time. B theory is tenseless, meaning that like there is no genuine distinction between past, present, and future. They're all equally real, and so on.
I see. Because like personally for me, I hold the view like I don't know which to hold, because personally I hold that like I would disagree with A theory that the future doesn't exist, because like in my personally I think like
you should
past
hold
and
to
future
B theory.
like
that's just the correct answer. The correct answer is B theory if you trust relativity.
Okay. Yeah, like I do trust relativity and stuff, but like for B theory, like I'm just having a little hard time trying to understand like what does it mean to be like equally real? Like, can you explain?
So in the same sense that you're at a place right now.
Yeah.
But to the left of you is a real place, and to the right of you is also a real place, including and where you are right now is a real place. All that's saying is that the same notion applies to time. To the past is real, the future is real, the present is real. They're all real.
I see. But like
it's just
like
treating time as another dimension.
Yeah. I guess the like kind of like thing I'm trying to wrap my mind around is that like I know it might like be intuitively hard to understand, because like of course we experience time and like kind of like a flow, but like of course B theory says like all of them are actually in a block already. So like like for past we say like it was, and for the future we say like it will be. So to say like is all is it's kind of like counterintuitive.
Look, you don't have to talk that way. This is just about what it actually is.
Yeah.
Like, I mean, we can still use tensed language for convenience because we exist. Like, we have this, this persistent illusion that now is special. But that is an illusion, at least if you trust B theory.
I see. So like, for relativity, like B theory would just fit way better in than just A theory.
Yeah.
Like what's the problem with A theory that you will say that
Yeah, so A theory kind of requires that there's a sensible notion of now that's well defined throughout the universe. And the trouble is that in relativity you have this issue of relativity of simultaneity. So what you might refer to as now, the set of space-time locations, or the set of space-time events that you might refer to as now, might be different from what some other person might refer to as now, even if they're at the same place as you, if they're just moving at a different speed. So depending on how fast you're moving, the now for you might be different from the now from somebody else. So that just means that there is again, at least if you trust relativity here, it means that there is no universal notion of now.
See. Yeah, like I was talking to one of my colleagues, and then he brought like, I think I'll call it an objection, I guess, but like he questioned about the B theory about like if time is like all contained in a block already, like how do you explain the direction, like why from the past to the future, like why not the other way around? Like how do you
explain it as you can explain it with like entropy. You can explain it with entropy is the typical explanation that's given. That is the direction in which entropy increases. So that's why we perceive in the direction of increasing entropy for perhaps biological reasons.
But like entropy, like why doesn't entropy go the other way? Like why does it have to be this way? Like how do you explain like?
Well, no. The point is just the way that we perceive time is in the direction of increasing entropy, because the way that a process, perhaps the way that memories form, can only form in lower entropy states than in higher entropy states, for example. I mean, this is all like a lot of this is like speculative, but like the question of the arrow of time isn't solved by A theory. So like that's an open question regardless.
Yeah. So I guess like personally now I would lean toward B theory, I guess.
Yes, let the hate flow through you.
So thanks for like clarifying like these inquiries. Yeah,
of course.
I'm trying to like figure it out. Yeah, thank you very much.
Of course. Take care, man. All right, let's go back to answering questions for a bit. Answering questions from chat. Man, Cable's crashing out in the chat. No, you don't like B theory? Sorry. What are K3 surfaces? I don't know. Is there a formula to calculate the thermal energy that happens from a collision? Yeah, it would be the difference in it'd be the total energy of the collision. So you take the final kinetic energy of the collision, subtract it from the initial kinetic energy of the collision, subtract off the sound energy lost, and that the rest, and basically the rest will be thermal energy. Is it worth getting a PhD in physics with its low salary and risk of funding cuts? You don't do physics for the money. So that's a you question. What's the most beautiful idea in physics to you? That matter tells space-time how to curve, space-time tells matter how to move. That's the most beautiful idea in physics to me. Thank you for the 25 knock, 25 Norwegian crowns, Eli. I'm looking to careers for physics. Which one should I look into? Depends on what you want to do. Can you be a good physicist even when you suck at solving first stage? I don't know what first stage Olympic problems are. Are you more a physicist than a mathematician? It depends on who you ask. Potentially, I'm actually more of a mathematician than a physicist. But the way I think is very physicsy. But the work I do is very mathy. So it depends. Most of your study is theory. Yes, I'm a theorist or a mathematical physicist. Yes, that is my job. Is it hard to afford life in a physics PhD? Well, yes, as a grad student, you will have a hard time. Grad life is hard when it comes to money. Are there any dimensions beyond 4? Not that we have evidence for. How does one understand linear algebra? By going to class and lectures, I suppose. What exactly is the difference between theoretical and mathematical physics? It's a good question. Theoretical physics is a lot closer to experiment than mathematical physics is. Mathematical physics is very much taking what we know about physics or speculating about what we think about physics and trying to say rigorous things about it, like trying to derive things that are certainly true given some set of physical assumptions or some set of physical conditions. So like Yeah, so like you could classify the set of all spacetimes that do XYZ thing, given some set of initial conditions. That would be a mathematical physics thing to do. What do you think of the black hole universe theory? I don't really buy it. So you believe in dark matter? Well, we have very strong observations of something that is causing anomalous gravitation in the universe. Gravitation beyond the matter that we observe. And the way that those anomalous gravitational observations occur very closely aligns with what one would expect if there were matter that we couldn't see. Do you have any merch? I don't have any merch, no. Do you believe in Jesus? I do not. What's your opinion on the recent UFOs? I don't buy it. Is spacetime non-analytic, meaning you can't really add two geometries of spacetime? Oh, it's not, analytic isn't the right word. It's non-linear. But it's also probably non-analytic. Meaning that knowing the spacetime in a small neighborhood probably isn't enough to get you the spacetime everywhere. Could you explain entropy to me as if I were 5? Yeah, entropy, the simplest explanation is that it's a measure of disorder. Can you wiggle your eyebrows? I guess. Does that count? Oh. Where's Ian been? No idea. All right, y'all. I think it's about time that I end the live. It's about 9 o'clock, which is what time I usually end these. You know, I'll take one more guest, and then we'll call it there. Let's bring up Oop. Misclick. Oh well. Sweet Pete, what questions you got for me? Sweet Pete, you there? Okay. Let's bring up Silas. Silas, what? No. Let's bring up Eli. Eli?
Remember me?
No. Should I?
From the other day?
No, I
Cooked
don't.
you in that debate with Joel Reeds and Mezzo?
No. But it may, if it was early in the morning, then I probably just don't remember it.
It was on Easter. Remember we were talking about prophecies, the Roman conspiracy.
Oh, yeah. It wasn't Easter for me. Yeah, what's up?
It wasn't Easter for you? Oh, yeah. Wait, where do you live?
Europe.
You don't sound European.
I'm not European.
Oh. You're just traveling there for now, or?
No, I just live here.
So you moved there, like you were born in the U.S.?
Yes. What questions you got for me?
I kind of wanted to talk more about the Roman conspiracy.
Okay, but that's not the topic for today. Let's ask a physicist.
Okay, but I do want you to have to concede the other. Yeah, I destroy you.
No, I don't think you did. Redefine, how's it going?
Can you hear me?
Yeah, I can. What questions you got for me?
Oh, great. Yeah, so I have a question on your take about, I guess, a problem regarding the laws of nature, or what provides for the uniformity of nature.
That's not really a physics question.
How is it not a physics? Doesn't physics presuppose that there are certain laws that the physical world is in submission to?
Yes, so physics doesn't answer the question. It presupposes that there are such things. It doesn't answer that question. It's not a physics question.
Okay. Do you have like an opinion on what that might be?
Nope.
Okay. All right then. I guess that's it.
Okay. So it does say ask a physicist, not ask a physicist. Well, I guess in principle you are asking a physicist even if it's not about physics, but like that is the point is to ask about ask physics questions, not like ask philosophical questions. Regular, how's it going?
Hello.
What questions you got for me?
So I'm about to go to college. I'm undecided.
Are you under 18?
No, I'm 18.
Okay, great. Undecided about what?
So, like in high school, my favorite class was AP Physics.
Mm-hmm.
And I hear it's really hard in college, but I feel like I would enjoy it too. So, do you have any advice?
Yeah, so how's your math?
I decided to just stop at probability and statistics, and I didn't do pre-calc yet.
Okay, then it will be hard. Well, okay, maybe not. How did you do in these classes? Like, did the mathematics come like pretty easily to you, or was it a struggle?
Yeah, for the most part, like as long as I understood like why the equations worked, then I like could do the equations, I guess.
So the thing that I so when I was an undergraduate, my math was very strong. And the thing that I noticed my fellow classmates who were struggling the most in the physics majors and the physics classes were the students who didn't have as strong mathematics as I did. So the advice that I would give for anybody, this goes for everybody, if you're going to major in physics because you love physics, great, do it. But keep in mind that you will struggle more the weaker your math is. Like, and it makes sense, right? Because when we do physics in the language of mathematics. And so what that means is if you're trying to learn the mathematics while trying to apply that mathematics, you're going to have a hard time. It would be like trying to learn Spanish while trying to do a literary analysis of Shakespeare in Spanish, right? Like you have to learn the language before you can apply the language. So it will be hard unless you can pick up the mathematics quickly. That said, what you could do, and this is what some people do, is they don't take their physics classes first. They do a semester or a year of mathematics to catch up and get good, and then they do better. It does put you a little bit behind in terms of time, so you'll have to cram more stuff into your last years, but it's doable.
Okay. And would you recommend like self-teaching in any way of like mathematics, like getting like algebra books and like calculus books?
So I wouldn't worry. So yes, absolutely, especially if you want to get ahead of it. That will certainly help you. Honestly, for the first year or two of physics, all you need is calculus, right? So sharpening up your calculus, teaching yourself calculus, even if you're going to end up having to take it again, because you probably will, you would need the college credit anyway. Just having that, having seen it before at least once, even if you were just doing it on your own, could be very, very helpful. And there's a lot of good online resources for this kind of stuff.
Okay, that clears a lot of things up for me as far as considering physics.
Yeah, I mean, look, I'm not trying to dissuade you. It's just people physics is awesome and it's super exciting because the ideas are amazing. But the way that we do physics is in mathematics, and so you're going to have a hard time unless you make sure that you're unless you make sure that you're comfortable with mathematics. So do the mathematics, and then do the physics. if you want. I mean, of course you don't have to. Nobody's making you.
For sure, yeah, because I now looking back at it, that was kind of my weakness as far as having I mean, it wasn't calculus, it was more just algebra. Bernoulli's equation has a lot of variables in it. Mm-hmm. And just remembering I basically learned reverse PEMDAS, which is very, I guess, primitive in your perspective, I guess.
Why reverse?
For
oh yeah, sure, I follow.
Yeah, so yeah, like looking back, I do realize math was kind of my weakness.
So my general position is that I don't think that math is like something that people are inherently good at, but it's something that people can become good at, and becoming good at it is easier when you're younger. Doesn't mean that it's impossible when you're older, but it does get harder. So you want to start sooner rather than later.
For sure. Well, I appreciate your guidance.
Yeah, of course. And feel free to DM me if you need any more advice. I mean, I'm not like a college counselor or anything, but I'm happy to offer whatever I can. Okay. So just let me know if you need anything.
Awesome. Thank you.
All right. Take care, brother.
See ya.
All right. And with that, everybody, I'm going to end the live because it's past 9 o'clock, which is when I usually end these. So thank you guys for being here. I appreciate you guys. I appreciate you all. And I'll see you guys tomorrow for some more debates. I might hop into somebody else's live later tonight. Who knows? But ta-ta.